Welcome, students. Today we're going to look at solving rational equations. Now, earlier in the semester, we looked at solving fractional equations, and because rational equations are so similar, we're going to recall how we solved fractional equations. So let's recall back to when we had to solve something like x over 6 equals 1/6 plus x over 8. There was a very important rule that we had when we wanted to solve equations with fractions in them. Do you remember what that rule is? We need to get rid of the fractions by multiplying by the LCD. We need to get rid of fractions by multiplying by the LCD. This is super important. It's so important that you should highlight it if you have a highlighter. If you don't have a highlighter, you should put a circle around it or maybe put a cloud around it. Anything that you can do to make this rule stick out, because I have found that students who don't follow this rule crash and burn. They make mistake after mistake after mistake, and they make things way harder than it needs to be. So please, this is one of the few times where I will beg you to follow this rule. Now, in this problem, the denominators are 6 and 8, and the least common denominator there is going to be 24. So what we're going to do is we're going to multiply both sides by 24. Remember that we do this by putting parentheses around each side and writing 24 on the outside. And the reason we need to do that is so that we make sure we actually distribute that 24. Now let's look on the left-hand side. 24 times x is 24x. If we divide that by 6, it gives us 4x. Then on the right side, 24 times 1 is 24. Divide that by 6, we get 4. And then plus 24 times x again is 24x. Divide that by 8, we get 3x. So by multiplying both sides by the LCD, we get rid of fractions and we make the problem a whole hell of a lot easier. Now we need to get rid of one of these variables, because we have variables on both sides. I'm going to subtract 3x from both sides. 4x minus 3x is x. And on the right, we're just left with 4 because the 3x's cancel. And we end up with x equals 4. This is a problem that we already knew how to solve. We know how to solve equations that have fractions in them. And that's exactly what a rational equation is. The only difference is that we might have variables in the denominator. So now, let's look at an example of a rational equation to solve, which is just an equation that contains rational expressions. Let's look at 5 over 2x equals 17/18 minus 1 over 3x. Even though there are variables in the denominator, the same rule is still going to help us. We have fractions, we want to get rid of them. We do that by multiplying both sides by the LCD. And we're going to do that in just a moment, but we're going to do one other thing first. We're going to talk about our restrictions. This is something that we've never seen before. And the reason we've got something new is because for the first time, we are solving equations where there are variables in the denominator. And there's an important thing that we have to keep in mind. We know that we're never allowed to divide by 0. So what that means is we can't have any denominators that are equal to 0. Now, in 17/18, this is not a problem, because we know 18 is not 0. But in these other denominators, 2x and 3x, those can be equal to 0, if x is 0. So if x is 0, we've got a problem, because then 3 times 0 is 0, and we've got a 0 in a denominator. We're dividing by 0. So the restriction we have on this problem is that x is not allowed to be 0. Now, why am I saying this? Because it's possible that we go through all the steps to solve this equation, and in the end, we end up with x equals 0. If that happens, we have to throw that away. It's not a real solution. We call it an extraneous solution, and I will write that out, but in another example when we actually have an extraneous solution. This one's not actually going to have an extraneous solution. We're not going to end up with any problems here. So let's go through solving this one. We're going to do a couple more examples, and we will eventually see one with an extraneous solution. For now, though, let's just multiply by the LCD. The denominators are 2x, 18, and 3x. The LCD here is going to be 18x. On the left-hand side, 18x times 5 is 90x, and if we divide that by 2x, we get 45. On the right-hand side, we're going to have to distribute this 18x. When we distribute the 18x to this first term, notice that the 18s are going to cancel. So we just have x times 17, which is 17x. It's a lot faster than taking 17 and multiplying it by 18 and then dividing it by 18. Now, in the other term, we've got minus 18x times 1 is 18x, and when we divide that by 3x, we get 6. And again, we have a simpler equation with no fractions. We can solve this pretty easily. We can add 6 to both sides. That gives us 51 equals 17x. And then to get x alone, we divide by 17. 51 divided by 17 is 3, and we get x equals 3, which we know is fine. The only restriction we had was that x was not allowed to be 0. It's okay for x to be 3, so this is a solution. If you want to check, you can plug it into the original equation. I will let you do that on your own time. It should work out. In the next video, we're going to do a couple more examples, including one that has an extraneous solution. So definitely check those out.